Hi students, today I am going to explain matter lesson. So what is matter? We see many things like people, clothes, glass, windows, books, walls, water, air and so many things. Whatever are the things, everything around us, whether it is living or non-living, all these constitute matter. So if they ask what is matter, what we have to write? Everything around us, both living things and non-living things are called matter. So we can see, so here they give an activity: fill a bowl with things you find around you like water or pebbles or even snacks, whatever it is. So then pick up the bowl, you will feel some weight. So what is that weight? And compare the weight with the empty bowl. So anything difference is there? Yes. So what is that? The bowl which is heavier when it is filled than before. Then try to lift a chair or a bundle of clothes. You will feel some weight. So all this weight is nothing but mass. Mass is nothing but amount of matter present in an object. So and all this will take some space also. So the amount of space that an object occupies is called volume. So now we can define a matter. So matter is nothing but anything that has mass and occupies space. So matter is anything that occupies the weight and also have space. So air also has mass and it will also take space. So the bowl looking empty, is it really empty? No, it contains air. So the substance that an item is made up of is called material. What is material? Whatever is the substance that item is made. Whether it is a dress is may be made up of cotton material, like that. Then classification of matter. So matter around us is classified into different, maybe depending upon their property, size, color and so many common properties like this. So matter is classified into solids, liquids and gases based on some properties. So there are three states of matter basically, right? So next we'll see first solids. Something we can see can be grouped together on the basis of their appearance. So by seeing their appearance we can say they are solids, like chair, pencil, books, walls, clothes. All these are examples of solids. They have fixed shape. So we can say solids have a specific size and shape and they occupy space and have fixed volume. Even solids have mass. So these are solids. We already told about the examples like furniture, clothes, rocks, books. All these have definite shape. They occupy space. They have fixed volume. They have mass. Right. Then liquids like water, oil and milk. All these are in liquid state. As no, liquids don't have shape. They will take the shape of a container and they also occupy space. They also have fixed volume and even they have mass also. See, water, they don't have shape. Water, juice, milk, honey, all these are liquids, don't have shape, but they take the shape of a container when it is filled and they occupy the space, right? And also have fixed volume, 2 liters, 3 liters, yes, no, and they also have mass. Then next is gases. So though we cannot see most gases, we know they are there. Can we see gases? No, but we know that gas is there. We feel that air when the wind blows. Yes, no, when we breathe deeply, even we can feel and hear our breath also. So like oxygen, hydrogen, carbon dioxide, these are all some examples of gases. Generally gases don't have color. They are colorless and they spread easily and occupy the available space. So gases don't have a definite shape or volume, but they have mass. So liquids and gases both can flow. So they are called fluids. Then here some activities they are given. So let's see the activity. Here, to prove that liquids have a fixed volume but not a fixed shape. So we have to prove that liquids have a volume but don't have fixed shape. Let's see. What are the materials required for that? Measuring jars of different shape like cylinder, conical flask, beaker. Then pour glass of water into the measuring cylinders. Note the readings and observe the shape of the water. Now pour all the water first into the conical flask and then again into the beaker, and note the readings in all the jars. You will observe that readings remains the same. So liquids occupy a fixed volume, and however the shape of the water changes. So depending on the container it is used. From this we can say water have a fixed volume but don't have fixed shape. Here, to prove that solids and liquids occupy space, let's see what we want for this. A glass beaker, water, glass trough, this is trough, stone, and a string. String means thread. So fill the beaker into the to the brim with water. We have to fill with water, and we have to place it in a trough, tie in a stone, and slowly immerse. When we immerse, what happens? The water falls into it down. From this we can see the water level rise up to the brim, and this proves the solids and liquids will occupy space. Then, so wheat is a solid, but wheat flour is a solid or liquid? Just find it. You might ask this because you can pour atta. Flours and powders can be poured because they are made up of small grains of substance. However, each grain is a solid, but if you pour atta on a flat surface, it stays in a heap. If you pour water, it runs. So it is the surface of a liquid becomes almost completely flat after it is poured, whereas this is not so for flours and powders. So it is a solid only. Then gases. To prove that air has a mass. So we know that air, how the mass is there. To prove that, 2 balloons we have to take, and a meter scale, and a pin, and a string. String is thread. The tie inflated balloons same size at a meter scale and suspend it using string so that the scale is level. Then scale will go down on the side with the inflated balloon. Yes, no, because it is heavier, and one side we punch it so that it will don't have air. It becomes less weight and it will come up, and it will the inflated balloon will come down because of heavy. This proves that air has weight or mass. Then one more they gave to prove that air occupies space. So you can do it in home. Trough, water glass, water. So take a trough half filled with water, invert an empty glass and push it down while still holding the glass under water. Tilt it slightly. We have to tilt it. Then we can see some bubbles escaping from this. This proves that air or any gas will occupy space. Then, what is matter made up of? So, take a piece of chalk or cube of sugar. Use a small hammer to break it into pieces until you get fine powder. Then you have to broken the chalk or sugar cube down to smallest unit. But the smallest speck of powder is million of times larger than smallest unit that made up of speck. So the smallest, when we make it into very small particle, that small particle we cannot make it again into small. That is the smallest unit of matter that shows the specific substance, properties of substance, and it is called atom. So what is atom? It is too small. We can even see only with a microscope. Even a speck of gold dust contains millions of atoms of gold. So all atoms do not exist by themselves in nature. They will join with same kind or different kinds of molecules, different kind of atoms to form molecules. So what is an atom? The smallest unit of matter that shows the properties of a specific substance. And what is a molecule? It is a unit of any substance that can exist itself in nature independently. Atom cannot exist independently. Sometimes it combines, but a molecule can exist independently. It is also very small. The molecules that make up of a pure substance are identical. Salt contains salt stacked together, and water contains molecules of water, like this. Then, what are the characteristics of molecules and states of matter? Let's see. The molecules within a substance attract one each other. So each molecule will attract with another molecule together, and it have intermolecular force of attraction or repulsion between these molecules. So these molecules may attract with each other or repulse with each other. And it also have the molecules also have a distance between them, both them. So that distance is nothing but intermolecular space. The space between the molecules is nothing but intermolecular space. These molecules of a substance will be always in motion. It will be always moving. It will not stay one side. So then let's see, understanding intermolecular space. So fill a beaker with pebbles or marbles. Make sure they are packed as closely as possible. So many pebbles we should add so that it will be tightly packed. Then add sand to the beaker. Shaking the beaker gently. Just shake it. Then you will note that in that spaces this sand will fill this. From this we can find this intermolecular spaces will be there between the molecules like this also. Same. Like between the pebbles sand is there. Like that between the molecules the space will be there. Then how the arrangement of molecules will be there in the three states of matter. So the state of a substance depending upon the force between the molecules. I told intermolecular force will be there depending on the strength of the force and also how random motion of the molecules. Means random means there will be no method, just order, just it will be moving. Yes, no. The solids. When we see solids, we know that they are strongly held at, because they are arranged very compactly. The intermolecular force will be very strong because there is space is very less. They are very close to each other. So intermolecular force is strong and space is small. So molecules are tightly arranged and they cannot move. So they can only vibrate in their position. So they will have different shape and volume. We cannot compress it because no space to compress only. Yes, no. Because of strong molecular force, if we apply force, it will break a solid. If you break iron, hammer it, or wood, it will just cut because of the strong intermolecular force of attraction. Then when we see liquids, so intermolecular force of attraction is little less than solids and space is more. And because of the space, the molecules can able to slide over each other. That's why liquids can flow, poured. Yes, no. The liquid can spread and the liquids cannot be compressed. So, and it will don't have shape. It will take the shape of a container. So, intermolecular space is more and force of attraction also less than solids. Then, gases. The gases intermolecular force of attraction is very less because they are very far. Intermolecular space is very high and gases move very easily and do not remain stationary. They can easily move. And gases don't have shape or volume. They can compress So when pressure is applied, molecules will push close to each other and occupy a less volume. Then what is cohesive force they gave? Have you seen liquids forming droplets? So they form droplets because of intermolecular force of attraction between the molecules of same kind, which is called cohesive force. So because of the I told intermolecular force of attraction will be there between the molecules. Because of this, this is also called cohesive force. Because of this, droplets are formed. And one more unique feature called Brownian motion. Liquids and gases, there will be rapid, constant and random movement. They are moving rapidly, continuously so that it will strike one another and it will also strike the walls of the container, and it is called Brownian motion. It was first observed by Robert Brown while studying about pollen grains mixed with water under microscope. That's why they gave the name Brownian motion. So he observed that the continuously moving water molecules hit against the pollen grains and pushed them in all directions. Then what is diffusion? So we can see some smell like samosas, pakoras being fried in the kitchen. When we enter the house only, we can find out they are cooking something. So how this is called a diffusion process means what happens? There will be a movement of substance from area of high concentration to area of low concentration. What is high concentration area? The more air will be having this smell to the place where low concentration means the smell will not be there. There it will move. So The molecules move from high concentration area to low concentration area. Degree of diffusion also depends on the state of matter. As solids are rigid, they do not diffuse only. Liquids diffuse into each other, whereas others such as water and oil do not. And molecules easily diffuse because of more intermolecular space between them. Then solids and liquids can diffuse through gases also. Solids and gases can diffuse through liquids as well under certain conditions. When samosa is cooked or agarbatti is burnt, molecules from samosa or agarbatti spread through air. Our nose will detect these molecules and will get a sense of smell. Then, what happens to solids, liquids and gases when heated? What happens? Temperature will increase, it will expand, it will change the state. State will be changed from solid to liquid or liquid to gas, like this. And even the chemical nature also will change. The first three, increase in temperature, expansion, change of state, these are all physical changes we can see. And chemical nature change is chemical change. Then how it expands we can see in solids, liquids and gases. When a solid is heated, the molecules will become more energetic because of kinetic energy. They will produce kinetic energy. More energy is produced. Their movement will become vigorous. Vigorous means very fast. And they move apart slightly. This results in expansion of solids. This expansion is often slight and we cannot see this. When solid is cooled, again it will become less energetic and again it will come to original position and it result in contraction. Then they gave one activity to prove how the solids expand. A ring with a long handle, a metal ball attached to it, we'll see the diagram. So a stand, a ring with a ball easily passing to it like this. After we heat it, it is very difficult to pass because it got expanded. Again after cooling, again it comes to original size and again it will pass easily like this. Then long pieces of metal expand along their length. So when we take a long piece of metal, it will expand along the length like railway lanes. Some gap is left between two railway lanes, consecutive rails. Why? Because in the summer, because of heat, sun's heat, the metal will get expanded. And if there is no gap, what happens? It will be difficult. The two trains will get dash. Yes, no. That is why they'll keep some gap. Then liquids. When liquids are heated also, they will expand like solids only, but more than solids. The molecules are more energetic. Their movement will become more rapid and random. And the movement of the molecules takes from further away from each other and liquids expand. Let's see it. How? See, to prove the liquids expand on heating, we want a test tube, test tube stand, water, ink, one hole rubber cork, capillary tube, spirit lamp. Take first water in a test tube. Then ink. Add ink to that water. So close the test tube with one hole rubber cork. One hole should be there. Insert in it a capillary tube through this hole and let it dip in the water. Now heat the test tube on a lamp. Repeat with other liquids also. We will see there will be a rise in the level in the capillary tube. This proves that liquids expand on heating. Then what happened to gases? Compared to solids and liquids, gases expand more. They energize molecules move further and further away from each other. For example, let's see how the gases expand on heating. Test tube, stand, colored water, one hole rubber cork, capillary tube, spirit lamp, same. So close an empty test tube here. Empty test tube. Push a capillary tube, colored water through the cork. Place a few drops of colored water in this capillary tube and heat. What happens? We will see this colored water will move upwards. Means air is expanding and it is pushing up. So from this we can see that air also expands. Then air also exerts pressure. Yes, no? So peel hard boiled egg. We have to use peeled hard boiled egg. bottle with a mouth slightly smaller than egg, strips of paper, matches. Place a few strips of paper inside the bottle, drop a burning match into it, immediately place the egg. The egg is slowly sucked into the, because it will exert some pressure, and the heat of the burning paper makes the air expand and some of the air escapes and a low pressure is created inside the bottle. The air outside has high pressure and hence pushes downwards, and this egg will fall into it. This is because there is no more air inside the bottle and it pushes the egg out to make space for itself. Then we can see comparison of solids, liquids and gases. We know that in solids there will be more intermolecular force, less intermolecular space, shape will be definite, fixed volume, we cannot compress, fluidity will be no, expansion of heating will be very small. Then in liquids, intermolecular force is less than solids, space will be more, shape no shape, volume will be fixed, we can little compress, it is hard to compress, fluidity will be there, it will flow fluid, more than the solids it will expand. Then intermolecular force is very weak, space will be more, no shape, no fixed volume, we can easily compress, fluidity will be there and expands more. Next topic, change of state. We know that water exists in 3 states of matter. When we cool or heat, it will expand, contract and it will change the states of matter. So why? Because of movement of molecules on heating and reduction of movement of molecules on cooling. So when liquid water is cooled, what happens when liquid water is cooled? So at its temperature decreases and at a certain temperature it will change into ice, a solid. So the change of a state of a liquid into solid on cooling is called freezing, or because it is forming solid, solidification. The temperature at which a liquid freezes is called freezing point and it is nothing but 0 degrees centigrade. Again, when water is heated, its temperature increases and at a certain temperature ice changes into liquid. So liquid water, again the change of state of solid to liquid, again ice is changing into, while heating water, again it is called melting because it is melting, ice is melting, or it is also called fusion, and this temperature is called melting point. So the melting point of ice is also 0 degrees centigrade. So the melting of point of ice and freezing point of water is same. Then change of state of a liquid into gas. When we heat the water, its temperature increases and at a certain temperature water will change into water vapor. So the water begins to boil and change into vapor. The temperature at which water boils is called, or water, any liquid is called boiling point, and the boiling point of water is, we know that 100 degrees centigrade, and this process is called evaporation because it is evaporation, vapors are formed, and evaporation and boiling are types of vaporization. Again when the steam is cooled, again it is cooled, again it will get condensed, it is called condensation or liquefaction. So and again it will change into water, and it also takes place at 100 degrees centigrade. So the condensation point and the boiling point is 100 degrees. Like that only melting point and freezing point is 0 degrees centigrade, same. So all this interconversion will takes place to solid to liquid, liquid to gas, it will be changing. So the interconversion of water is very important. Why? Because the water cycle will exist because of this only. So see here, again I am going to change solid. When we heat it like ice, it changes into liquid. When again it is freezed or cooled, it will become solid. Then solid directly converting into gas, it is called sublimation. For example, camphor, when it is heated, it will not change into liquid, it will directly change into gas. This gas again when it is cooled, it deposition on cooling. Then liquid when it is boiled, water boiled, it change into vapor. So gas, vaporization and heating. Again when it is cooled, condensation. Again water droplets are formed. Again water is formed. Like this we can see. And sublimation, as I already told, a substance directly convert from solid to gas without melting, like naphthalines, iodine, like this. They directly sublimate. And reverse of that is deposition. Vapors directly becoming solid on cooling. Like this we can see. So when we see in wardrobes, we'll put naphthalene balls. After a month or 2 months, what happens? It all got sublimated. We cannot see that. Yes, no. Why we'll keep naphthalene balls? So it will help to keep away from insects and moths because of their strong smell. Then we'll see change in chemical nature. So now we saw physical change. Now we are seeing chemical change. There are different types of changes, physical and chemical change. When you burn a match or a piece of paper, soot and ash are formed. When vegetables are cooked, their chemical nature will change. All these are examples of chemical change by heating. Then types of change, I already told, physical change and chemical change. Physical change, no new substance is formed. So when water is heated or cooled, it will change the state. Again when it will become the same again. So it is temporary and it can be reversed. Like tearing of paper, breaking of glass, all these are examples. Cutting of wood, sharpening of pencil, all these are physical changes. When we see chemical change, there will be a new substance formed. So one or more new substance is formed, and the properties of new substance will be very different from the original ones, and we cannot reverse it. Like if we burn the wood, heat and smoke are produced, again we will get the wood. No, it is impossible. We will get only ash. And the rusting of iron, even rust is also a new substance. Rotting of bananas, digestion, photosynthesis, all these are chemical changes. That's all.